Hello friends, in this video we will let to know everything about the first observatory class space-based solar mission from India called Aditya L1 that will be launched by ISRO most probably on 2nd of September 2023 after the successful launch of Chandrayaan-3 mission. Our Sun is the nearest star and the largest object in the solar system. The estimated age of Sun is about 4.5 billion years. It is a hot glowing ball of hydrogen and helium gases. The distance to the Sun from the Earth is about 150 million kilometers and is the source of energy for our solar system. Without the solar energy, the life on Earth, as we know, cannot exist. The gravity of the Sun holds all the objects of the solar system together. At the central region of the Sun, known as core, the temperature can reach as high as 15 million degrees Celsius. At this temperature, a process called nuclear fusion takes place in the core which powers the Sun. The visible surface of the Sun, known as photosphere, is relatively cool and has temperature of about 5500 degrees Celsius. Why there is need to study Sun? The Sun is the nearest star and therefore can be studied in much more detail as compared to other stars. By studying the Sun, we can learn much more about stars in our Milky Way as well as about stars in various other galaxies. The Sun is a very dynamic star that extends much beyond what we see. It shows several eruptive phenomena and releases immense amount of energy in the solar system. If such explosive solar phenomenon is directed towards the Earth, it could cause various types of disturbances in the near-Earth space environment. Various spacecraft and communication systems are prone to such disturbances, and therefore an early warning of such events is important for taking corrective measures beforehand. In addition to these, if an astronaut is directly exposed to such explosive phenomena, he/she would be in danger. The various thermal and magnetic phenomena on the Sun are of extreme nature. Thus, the Sun also provides a good natural laboratory to understand those phenomena which cannot be directly studied in the lab. Now, let's talk about the first observatory class space-based solar mission from India called Aditya L1. Aditya L1 is the first space-based observatory class Indian solar mission to study the Sun. The spacecraft is planned to be placed in a halo orbit around the Lagrangian point 1, L1, of the Sun-Earth system, which is about 1.5 million km from the Earth. A satellite placed in the halo orbit around the L1 point has the major advantage of continuously viewing the Sun without any occultation eclipse. This will provide a greater advantage of observing the solar activities continuously. The spacecraft carries 7 payloads to observe the photosphere, chromospheres, and the outermost layers of the Sun, the corona, using electromagnetic and particle detectors. Using the special vantage point of L1, 4 payloads directly view the Sun, and the remaining 3 payloads carry out in-situ studies of particles and fields at the Lagrange point L1. The suite of Aditya L1 payloads are expected to provide most crucial information to understand the problems of coronal heating, coronal mass ejection, pre-flare and flare activities, and their characteristics, dynamics of space weather, study of the propagation of particles and fields in the interplanetary medium, etc. You must have a question here about what is L1? So, L1 is known as Lagrange points. For a two-body gravitational system, the Lagrange points are the positions in space where a small object tends to stay if put there. These points in space for a two-body systems, such as Sun and Earth, can be used by spacecraft to remain at these positions with reduced fuel consumption. Technically, at Lagrange point, the gravitational pull of the two large bodies equals the necessary centripetal force required for a small object to move with them. For two-body gravitational systems, there are total 5 Lagrange points denoted as L1, L2, L3, L4 and L5. The Lagrange points for Sun-Earth system are shown in the figure. The Lagrange point L1 lies between Sun-Earth lines. The distance of L1 from Earth is approximately 1% of the Earth-Sun distance. The Aditya L1 mission will be launched by ISRO PSLV rocket from Satish Dhawan Space Center, Sriharikota. Initially, the spacecraft will be placed in a low Earth orbit. Subsequently, the orbit will be made more elliptical, and later the spacecraft will be launched towards the Lagrange point L1 by using onboard propulsion. As the spacecraft travels towards L1, it will exit the Earth's gravitational sphere of influence, SOI. After exit from SOI, the cruise phase will start, and subsequently the spacecraft will be injected into a large halo orbit around L1. The total travel time from launch to L1 would take about 4 months for Aditya L1. Now, the major science objectives of Aditya L1 mission are: Number 1. To study of solar upper atmospheric, chromospheres and corona dynamics. Number 2. To study of chromospheric and coronal heating, physics of the partially ionized plasma, initiation of the coronal mass ejections and flares. Number 3. Observe the in-situ particle and plasma environment, providing data for the study of particle dynamics from the Sun. Number 4. Physics of solar corona and its heating mechanism. Number 5. Diagnostics of the coronal and coronal loops plasma, temperature, velocity and density. Number 6. Development, dynamics and origin of CMEs. Number 7. Identify the sequence of processes that occur at multiple layers, chromosphere, base and extended corona, which eventually leads to solar eruptive events. Number 8. Magnetic field topology and magnetic field measurements in the solar corona. Number 9. Drivers for space weather, origin, composition and dynamics of solar wind. The instruments of Aditya L1 are tuned to observe the solar atmosphere, mainly the chromospheres and corona. In-situ instruments will observe the local environment at L1. There are total 7 payloads on board, with 4 of them carrying out remote sensing of the Sun and 3 of them carrying in-situ observation. I hope you liked the video. Have a great